Hey everyone, thanks so much for joining this webinar on complexities faced with Kubernetes in production and how Logz.io's Kubernetes 360 specifically addresses these challenges. Joining us today is Customer Account Manager Danny Rivers and Customer Success Engineer Sean Pitts for this webinar to hear what they're hearing from our customers and how Logz.io's Kubernetes 360 solution completes the monitoring puzzle. So feel free to message me with any questions that arise throughout this presentation, and we will try to get to them all if we have time. All right, so kick it away, guys.
Thanks, Isabella. So as Isabella had mentioned, the point of this webinar is to address the complex challenges that come up when monitoring a Kubernetes environment, and how you can help to understand how to manage the costs now and as you scale. We'll also, at some point towards the end, kick it off to Sean to walk through a demo where he can show how to actually go through some of these challenges and how you can troubleshoot them effectively with Logz.io. So to start, I wanted to bring up some recent results that we had from our observability pulse survey. We interviewed over 500 professionals on where they are with their observability today and the challenges that they're seeing. It was interesting to see that over 80% of people take about an hour or more to find a resolution for production incidents. This was a little less surprising once we understood that about 50% of people were just lacking the knowledge on how to go about observability in the first place. 10% said that their observability was fully built out. Only about a third were partially there. So leaving over 50% of people with little to no observability in place today. And out of these challenges, over a third of people mentioned that Kubernetes is a big challenge when it comes to troubleshooting. So diving into why this may be, Kubernetes has a lot of complex challenges, as mentioned previously. The issue isn't understanding that a pod crashed and a new one was spun up due to, say, a spike in your memory. Where the challenge is really coming from is understanding where that spike in memory came from in the first place. And that's why having observability around your telemetry data is so important. So when speaking with our customers, we've really found out that they're left with two choices. One is to build something out on their own. This takes a lot of engineers' time, and you need to dedicate people specifically to monitor your monitoring solution, which isn't an ideal way to solve this. So what you can do is you can look at a managed solution to solve this for you. And when doing so, that comes with its own challenges. Figuring out how easy is this going to be to implement for my team? Am I going to get the correlation between all of my data in an easy to read manner? Will it be able to scale effectively as I continue to grow? And what's most important for a lot of people is how much is this all going to cost me? And when it comes to looking at the cost itself, it's really important to understand the size of your environment because Kubernetes produces a lot of data. Some of this is extremely important and will help you remediate quickly and effectively, but a lot of it may not be important to you. And it's also important to understand your cardinality so that you can adjust it appropriately in order to reduce the volumes of the data that you're sending. And I always tell my customers it's important to really ask three questions. Am I receiving all of the information that I need? Out of all of the information I'm receiving, is it all important to me? Or am I paying for data that I may not actually be using? And if there's ever like a spike in my data, am I able to cap this so that I'm not paying absurd overage charges throughout the month? So now that we've kind of understood a bit about some of the challenges that you'll face, some ways that you can go about fixing these and the costs that would be associated with it, I'll hand it over to Sean to walk through a specific use case.
Yeah, awesome, Danny. Thank you so much. So today I'm going to be walking through a specific use case scenario where we get a high number of pod container restarts within our environment. So let me share my screen. And you can see here, that I have received a Slack alert that's telling me that the amount of pod container restarts is high on the recommendation service, and it's coming specifically from this environment. Now, I've configured this alert on the back end, and I will explain how that's done. But for the sake of example, let's just click on metrics, and you're going to see that this opens up Kubernetes 360 in Logz.io. So we can see here that we're in the correct pod that's causing the amount of restarts. Now, if I look at the metrics that's actually occurring here, you can see that my pod memory has a good amount of spikes occurring. And then the container restarts as well is correlated to that. So as I receive spikes in memory, I'm getting a large amount of container restarts. Now, I'm not 100% sure why that's happening just from this view alone. I could look at the logs specifically if I do know what these mean. And this is why it's important, as Danny was mentioning, to understand your log data to be able to correlate it with your metrics. So if I take one step back and go one higher at the actual deployment view, which deploys these pods, you can see in the metrics view here that I am going to get the memory usage per pod. And we can see that right before the spike in memory, there's actually a flag or a deployment marker that's been set. So if I click on this deployment marker and click on the view commit, you can see that there has been a commit that has been released up to or pushed up to GitHub that's telling me that the cache has been changed from false to true. Now, it's safe to assume in this specific use case that setting that to true has caused a spike in memory usage per pod, and that in return is giving me a crashback loop, which is resulting in a high amount of pod container restarts. Now, we could look at the deployment view as well. So if we wanted to look at the logs and maybe understand, hey, if I search for cache hit or cache miss, what is happening? You can see here that I'm getting quite a few cache misses as well as cache hits. So we can see that this feature flag is indeed what caused the issue. Now, that is a very specific use case, but what if I want to just look at Kubernetes 360 holistically? One of the big problems I hear from customers, Danny hears from customers, is that it's really hard to get a holistic view of your Kubernetes environment. So what you can do is, let's say we're running a multi-region cluster or just multiple clusters. You can see that we could take from the node view, and we could also filter on the left-hand side which cluster we actually want to look at. So let's say I wanted to look at demo 4. In this case, you can see it'll append to the top, and I'll get all the nodes associated. This is running on an EKS environment in Amazon. So you can see that these nodes are going to be EC2 machines running. We get very high level metrics like node CPU, node memory, and the disk percentage. If we also look at the bottom bar here, you can see that we get overview, status, which gives us the amount of pods running, if there's any unhealthy pods, as well as the CPU, memory, pod restarts, and log error rate, as well as security risks. So we can break it down specifically from those. But let's say I just wanted to jump into the overview, and I want to look at one specific node. So if I click in here, you can see that I'm going to get all of my pods that are running within this specific node. I can see that there's 2,995 security risks. So if I click on the security tab, you're going to see that I get a bunch of CVEs that are attached to my pods. So if I have maybe a security vulnerability in one of my containers that are running on a pod, I'm going to get this in the security risks of my node, specifically as well as in the pod. If I want to see the logs, metrics, or traces directly from this node itself, I can go into the logs, metrics, or traces tab. And this is going to give me my spans. This will give me my CPU, my node memory, but it'll also give you the metrics here on the top right. So if I look at the logs specifically, you can see that I'm looking at the last hour. But if I want to drill down into a pod specific view, I can actually click on a specific service, and then I can see the pods or the logs, metrics, traces, and security vulnerabilities for these specific pods. On top of that, if I want to break it down by workload, so maybe I'm running a deployment, a daemon set, a stateful set, or a job, I'm able to actually filter by those as well. So if I want to take it from a different view and maybe not just a high level node, I can do so. But essentially that is Kubernetes 360 in a nutshell. It's really just a unified view of your log, metrics, and trace data to be able to unify that experience. Awesome. Isabella, do we have any questions from the crowd?
So 1 second, let me pull up my chat. All right, so I have one here. How do I get telemetry data from my cluster into Logz.io?
Yeah, it's a great question. So there's a few ways we can do it. However, the easiest way to do it is through the Logz.io collector. So in the data hub on your main account in Logz.io, what you'll be able to do is actually create what's called a telemetry collector. Now, you can see if I create a new collector, in this case, what we're going to be able to do is choose from a variety of integrations. This could be running on a localhost Linux machine, but in this case, let's say we want to collect from Kubernetes EKS. So if I'm running a Kubernetes cluster in Amazon, what I will get is a Helm chart. However, what I can do is click on the advanced settings, and this will give me the configuration options I need to be able to collect specific data. So let's say I want to name this Sean's environment, and I do want to configure taints and tolerations instead of, and maybe not AWS Fargate, which I'm sure we'll get to. You'll also see that we have logs, metrics, and traces that we can collect. One thing Danny mentioned when talking about cost is that a lot of these pre-built exporters for Kubernetes services will give you a ton of metrics. I think it's something like 40,000 I've seen in the past by default. And when you're trying to cut down unique time series, you're not going to want to deal with 40,000 unique time series. What you're going to want to get is just the ones that are recommended or the ones we need for Kubernetes 360. So you can also toggle that on, as well as security, name your environment, and these will funnel through as logs, as well as the deployment events. So if we toggle all this on, and then we click next, you can see that we can select our accounts. So maybe we have multiple logging accounts we want to ship the data to, multiple metrics accounts and tracing accounts, we can do so. Once we save those changes, you can see here that we actually are given our Helm install command, and all we have to do is run that on our cluster, and it'll start to pull that data through Fluentd, through Kubestate metrics, the node exporter, and OpenTelemetry through tracing. So that is the easiest way to get telemetry data in from your Kubernetes cluster. Awesome.
All
Any other
right,
questions?
awesome. Yeah. So we have another one here. How do you guys handle this for Fargate?
Yeah, great question. So Fargate runs a little bit differently than if you were to just run specific EC2 nodes in Amazon, right? Fargate does a lot of that work for you in terms of scaling, choosing the right instances, and so forth. So the way that it works is instead of running daemon sets, which will be configured under the hood when running something like the node exporter or the Kubestate metrics, what it will do is it'll actually run a high level collector, which will collect from all your nodes. And then that'll funnel the data there. So as I mentioned in the advanced settings that we can configure on AWS Fargate, and this will actually strip out daemon sets because daemon sets aren't supported in Fargate. So what will happen is it'll run it as a standalone collector. And this will allow you to still collect all those Kubestate metrics directly from your Kubernetes cluster running on Fargate. Awesome.
All right, we just got another one come in. You mentioned cost efficiency. How does Logz.io help manage costs?
Yeah, another great question. Oh, Danny, did you want to take it?
Yeah, I'll just do a high level and then maybe you can show a bit. I just wanted to mention earlier, one of the points was around being able to cap if there's a spike. We know a lot of people don't really offer a cap option. In Logz.io, you're able to give yourself an amount of overage if you need it, if you ever go over, but you can cap that at whatever you need, and you can even cap it at your plan to prevent any on-demand costs. And then Sean had also showed when it comes to Kubernetes itself, you can only collect what's needed. And beyond that, we do have the data hub, which I'll let Sean show that essentially will show you what's not being used in an alert or dashboard, so that you can sort through and see if that's information that you want to filter out as well. We found when it comes to Kubernetes metrics, we're on average able to cut out about half by the time you actually set up your your entire environment. So I'll let Sean kind of walk through this a bit.
Awesome. Yeah, Danny, thank you so much. So the Data Hub is a piece of functionality Logz.io rolled out to help you manage cost and manage the amount of data coming into the platform. So you can see here that if we're looking at logs specifically, it'll tell you what you're actually not using in terms of log data. The same goes for metrics. So if we're looking at things like the latency bucket, the latency count, specific metrics that are coming in with that, you can see that there's things that are going to be labeled as not used. And there's going to be metrics that are labeled as alert or dashboards. So you're going to want to be cautious if you're dropping this data. So what we can do from there is we could configure a drop filter on a specific metric, including specific labels. Now, if you are unfamiliar with what makes up a unique time series, let me break that down just real quick for you, and I'll help clarify anything. So if we look at a specific metric, let's say we have the calls total. You can see here that we're going to get all of our metrics coming in to Logz.io under calls total. However, let's say we have the calls total metric from app A and a calls total from app B. The app A and the app B is going to cause two levels of cardinality, which means we're going to have two unique time series. But you can imagine scaling that out. Maybe you have unique identifiers that are sending labels through a job ID or your pods, right? So maybe that is going to increase cardinality, increasing spend. If I want to manage that, what I can do from the Data Hub is I can create a metrics drop filter, which allows me to actually choose an account on my Logz.io region. Then I can click the metric name and the label that I want to drop. So let's say specifically, if I wanted the cloud region equals US East 1, and I want to drop all US East 1 calls total metrics, I can do so. However, not everyone wants to do that, right? That's a level of granularity you might not need. Instead, what you can do from the Data Hub is actually create something called a rollup. Now, rollups reduce cardinality. So let's say we had a time series data that was calls total app A, calls total app B, and maybe I didn't care about the app label at all. What I could actually do is click add a rollup, select the account, choose the metric name, and then choose the dimension to roll up, or essentially ignore. So if I wanted to ignore, let's say, the environment ID, and I have it, and I know it's a metric such as a gauge, that means it can go up or down. The difference between counters and gauges is counters continuously increase, something like request rates, or you have things like gauges. So maybe that would be like transaction price, right? Or that could be memory usage. So anything that goes up and down. But let's say I want to roll this up and I want to ignore my environment ID to reduce my cardinality. I can do that from here. And then I just choose my aggregate function. I can do a sum, max, mean, count, last, so forth. And then I can drop the original metric. So that means I'm not going to worry about that existing metric that comes in. I'm only going to get a new one with that label that's been pulled out. So essentially what we'd be doing here is, let's say we had calls total with the environment ID equals A, environment ID equals B. Since we're ignoring this environment ID, it's only going to be one metric now instead of two. So that's going to reduce your cardinality, but you can imagine if you have a bunch of unique time series that have unique identifiers such as job ID or pod, if you drop those labels, it would reduce your time series dramatically. So that is just two ways that we can reduce cost, but you can also do it from the configuration side. So if you did want to modify your Helm chart, we do use a Prometheus exporter. So you could actually use a relabel config if you're familiar with those to be able to reduce that. But there are options in Logz.io. Great. Any other questions, Isabel?
Yep, I just got another one. It asked, do you have any pre-built content in terms of alerting and dashboards around Kubernetes?
We absolutely do. So we are built on open source tools such as OpenSearch and Grafana. So you can see here that if we go into the integration side of things and we click on pre-built content, you're going to see that there's actually an option for Kubernetes here. And then if you click on install content, this will create a bundle such as metrics alerts and metrics dashboards. So if we go into the metrics tab, which will open Grafana, you can see under alert rules that we get Kubernetes 360 alerts already pre-configured. This will allow you, if you're already familiar with Grafana, to configure a contact point, a notification policy to alert yourself to, let's say, Slack, PagerDuty, OpsGenie, ServiceNow, Jira, Microsoft Teams, you name it. So that's what we give you for pre-configured alerts. You'll get things like cluster memory usage, daemon set rollouts, deployments, job cron, job fails, right? Node not ready, and so forth. In terms of dashboards, if you go into the grid icon and go under Browse, if you click on the Logz.io dashboards, you're going to see that we get things like Kubernetes 360 cluster stats, deployments, node stats, and so forth. So if we want to look at what we give you for the cluster stats specifically, you can see you are able to filter this, and this will give you things like the total CPU cores, memory, disk, nodes, CPU utilization, and so forth. So yes, we do have out-of-the-box content. However, since we are built on Grafana and OpenSearch for logging, Grafana for metrics, you're able to create customized dashboards and visualizations as you please. And if you ever have any questions, please reach out to us and we'll help. So,
All right. Awesome. So if we didn't get to your question that you messaged me, please reach out to us at team@Logz.io and we'll get back to you. Also, apologies. I never pronounce telemetry. I just can never do it right. So every time.
it
All
happens.
right. Awesome.
Great. Thanks so much, guys.
Thank you. Take care, everyone.